Excellent. Thank you, Danielle. Thanks to the council for asking this team to present one of our current projects as it relates to energy and net zero and sustainability. First of all, can everybody hear me okay? I can see a couple of faces because I've got my full screen of my slide. Yep. Yeah, sure.
We can hear you.
Yeah, we can.
Everybody can hear well. Okay, excellent, good. I know most of you on the call, but for those of you that don't know me, Ray Wolfe, I'm an architect with Thinkspace Architecture and a partner, and I'm also a member at large with the A4LE Council. And also on the call today in the Zoom room, Monte.
Hi, it's a privilege to be here. My name is Monte Paulsen. I'm the Passive House Services Lead at RDH Building Science. We're doing about 5 million square feet of passive house. We're starting to get the hang of it. We're also doing quite a few net zero projects, zero carbon projects, and other energy standards.
Thank you, Monte. And Patrick?
Hi there, I'm Patrick. I'm with the AME group. So we were involved in the design with Ray and team, and we're on the mechanical side. Also, just a quick note, I was working for Matt Younger for the past 9 years, so it kind of feels like I'm filling in for him here today.
Okay, good. Thanks, Patrick. And then two co-presenters who have helped us put this presentation together and are on the call as well. We have Mo Khan from OM Engineering, and also Selena Ajula from Thinkspace, who's our sustainability lead here at Thinkspace. And they're on the call, and we'll ask them to come on when we get to the question period at the end. So for what we want to go through, we have till about 1:15. We thought we'd present for about 45 minutes and 15 minutes of questions. I don't think we'll actually be presenting for 45, but we'll see how it goes. This is going to be recorded. And Donna, I don't see the dot. Oh, I do. Okay, so it is being recorded, just so everybody's aware. And it will be posted on the BC chapter website. So if anybody wants to view the presentation after, it's in the public domain. So feel free to access the content and information. As well, just some Zoom room etiquette. If you could leave your microphones off and your cameras off, that would be great, except for the presenters. In terms of questions, we'd love it if you posed questions to us through the chat line on the Zoom panel. We'll see if we can get to it during the presentation. Most likely, we'll probably get to some of your questions through some of the slides. But certainly, if we don't get to your questions, we'll have an ample opportunity at the end to review what your questions are. So why are we doing this presentation, and what are we hoping to accomplish? Thinkspace and the team were involved in what we understand to be the first net zero energy PDR in the province. It was a bit of a guinea pig project, and I really felt it was important to share the lessons learned so that some of the hiccups we encountered and lessons learned could be shared with everybody throughout BC, because I know there's a lot of people on this call that are also doing PDRs. So ideally, this presentation will help school districts and other consultants tackle PDRs, not just PDRs, but specifically as it relates to some of the energy options that I know the ministry is asking us to look at and accomplish in perhaps a very much of a tangled way, in that many teams are going in different directions. So we're hoping to help consolidate thinking. The other thing we want to do is debunk the myth of net zero, and this is just coming from our experience of ourselves going through the hoops of trying to understand it. And hopefully by the end of this presentation, we'll have a better understanding of the terminology and where we think things might be going. And then ideally, why are we doing this? We're all here because we're interested in and/or members of A4LE. We want to make better schools for students, and we want to make the next generation be the most sustainable community that it can be. So we're going to look at some big ideas, but we're also going to use this specific project, Site 207, which is now called Tatulu, the actual name of the school, but we're going to call it Site 207 in this presentation. It's a project with SD36. It's now in design development. So this is a real project and was a real PDR, and we thought this would be a good lens or a filter for our conversation. And so we'll be referring to this to help illustrate some of the ideas and lessons learned, and also some recommendations. This is also the first three-story school for School District 36. It's an urban compact site. It's a very, very tight site. It's a large elementary school, 655 students, and it's currently going to tender in the fall of 2021 and will open in the fall of 2023. So a bit of base terminology, I'm not going to kind of get into the nitty gritty of it, but if we start at the top of the screen in the terminology and then kind of work our way down, the first two definitions are about energy, and then the latter definitions are about carbon. It's interesting because on Site 207, we started at the top and we sort of said, well, okay, well, it's energy. And also the ministry had a focus, the word energy was paired with the term net zero when we first got involved in the PDR. So really, net zero energy is really whatever energy you're generating on your site, you want to offset it with something that's clean, and so that you're balancing yourself out. It's almost kind of like when you fly and you're chewing up all that fossil fuel, but then you're also paying some money doing some carbon offsets. That's kind of my interpretation of net zero energy. Of course, net zero energy ready would be just making the school so that all you need to do is plug in the solar panels or whatever strategies you have to get it to that point of net zero energy. So it's about ability to also use fossil fuel consumption, but then you're offsetting. Greenhouse gas, that's the byproducts. I think we're all familiar with that. It means carbon dioxide, methane, and nitrous oxide. That's all the bad stuff that's making our bad environment worse and worse every day. But then at the bottom of the screen, the definitions actually are about carbon. And so net zero carbon is, you could still use fossil fuels or electricity or clean energy, but you're actually not as concerned about the energy offset. You're actually concerned about the carbon offset and making sure that the carbon that you're generating is being offset through another means. And then of course, the ultimate goal would be a zero carbon scenario where you're not actually burning any fossil fuel. And that would be an amazing situation to be in. So again, if we go back to kind of the start of this kind of the story of net zero energy, well, that's what the ministry came to the stage with and said, well, how do we make a net zero energy school? What's our baseline? We know our unit rates for schools. We're all familiar with working with our QSs and starting with the unit rate, but well, what's the option or two options, and how much is it going to cost to get to net zero energy? Really what that pushed us down was a track of looking at net present values, and it created a product or an ultimate design that really was fossil fuel burning. But there's kind of some other things that we're missing, and sometimes you don't know until it's too late and you've already done the work, and then you reflect back and you go, well, we should have done this, or that. So Monte, over to you.
Okay, thanks. That's a great warm-up. The difficulty with net zero is that it's not well-defined. And just think with me for a minute what it might be. If you pitched a tent on your summer camping trip and you had just enough solar cell to run your batteries or whatever you had, you're net zero. You're basically functioning as net zero by lowering your expectations. And in a school, if you were looking for the cheapest possible net zero school, you would build a school probably of portables and a whole bunch of solar panels. It's sort of the scholastic equivalent of the tent to some degree. Conversely, you could take just about any building, and if you put enough solar on it, fields and fields and fields of solar PV or some other form of renewables, you could accomplish a point where you generated enough power during the year to offset the power you use during the year. It'll never work out perfectly because you're probably generating more in the summertime and you're probably consuming more in the wintertime. So you're still relying on BC Hydro or some other service to form a bank or a battery. There's also a question of how you decide you've achieved net zero. Do you achieve it by an energy model, when we'd say modeled net zero, or do you achieve it by actually proving it, making the school perform for a year or two and show that you've actually generated as much as you used? How do you make those calculations? There's criteria differences you could look at. Are you going to allow combustion or other pieces as part of that? Over what time frame are you looking to be net zero? If you were really trying to lighten the load on the grid, you try to do it on a shorter time frame. And are you looking for some third-party confirmation, or are you just going to say, well, I put some solar on top, so it's net zero? So you're going to have an engineer or some other accredited professional issue a report saying, yes, this is net zero, or even go for a building certification. And several of the building certification programs have various forms where they acknowledge or certify that it's net zero, either based on modeling or based on measuring. I think the other key thing to recognize that is at this phase in North America, an awful lot of the buildings that claim to be net zero through one of these approaches don't actually achieve their targets. There's a real performance gap that comes for a whole variety of reasons, and all makes this kind of tough. I'm gonna move ahead. At the crux of the debate, as you weigh various times of net zero, and it is complicated, we're not going to try to go through it all today, but there's two basic ways to think of it. The traditional net zero approach, and the Joyce Center for Partnership and Innovation in Hamilton, Ontario is a good example of this. You can see they've got those big roof wings over the building. Those are covered with solar photovoltaic panels. And basically the exercise is they said, okay, here's the largest PV array we can put on this building. Now we're going to design the building and look at every single load to bring it down within the amount of power we can generate. And so it's a PV first approach. And the Joyce Center is operating. It's been operating for, I think, a little more than a year now, and is operating at a net zero basis. In other words, it is generating slightly more than it's using on an annual basis. But it results in a building that's relatively conventional with these additional systems. The other approach that is more common at this point in Europe, although there are some pass-fast schools in the States at this point, is to build a little thicker wall, a little bit different type of building that's a little more conservative in its general approach and has less heat loss, maybe can cool itself better. And then you lower the amount of energy you need dramatically, so that if you wanted to make it net zero, it would be a much less amount of PV you'd put on top. Or you might just decide that at that point you've lowered the load so far, you're not going to worry about hitting that technical net zero calculation. So that's the pass-fail approach, although that's also pursued by Step Code and many other approaches at this point. And so this core debate was kind of where we started as we were looking at Site 207. I'll move ahead there. Ray's got the clicker. And so what happened in this exercise, and what happens in an awful lot of these exercises, you get driven by these two calculations. What meets net zero? How could we create a cost-effective project that generates as much energy as it consumes? And what does it the cheapest? So you keep running these net present value calculations alongside it, and you're asking what is the both cheapest to build initially and the cheapest to run. This project ran some numerous variants, quite a few options. But the most cost-effective options all clustered around the same idea, that you would create a school that was pretty much a code-built school, maybe a little bit more robust, but not that thick a wall, not that well-defended windows or otherwise. And you would run a gas boiler, because fossil gas is very cheap in our province at this time, and the installation of fossil gas boilers as means to heat the space and the hot water is very affordable. It's highly subsidized. And then you'd put on solar PV panels on the roof to offset the amount of energy used in gas. You're not making up for the fact you have greenhouse gas emissions. You're not making up for the gas itself. There's no way to replace that. You're just putting a PV panel, as Ray said, kind of like buying a credit when you fly and saying, well, we've generated this amount of power and we've put this many kilowatt hours back into the grid for BC Hydro to offset the gas. And to be honest, every time a project does, every time the lens is net zero plus NPV, this will be the answer you'll get at this point in time. This is just the way the economics work on almost every project, certainly every school project, but other types of projects as well. If the criteria is net present value plus net zero, you're going to come up with this idea of a gas-run building with some PV on top. I want to go to the next slide there. And this is kind of where we had the record scratch in this team, and it was a great team and really fun to work with Ray and the other consultants, is we realized, is this the definition of net zero we want to teach our kids? I have two kids, one in elementary school and one in high school, and as we try to set examples for them, do we want to say that the right path to the future is this math game where we're still burning fossil fuel, we're still contributing quite a bit of greenhouse gas emissions, we haven't really changed or upgraded the design of the school and made it that different in terms of health and comfort and other pieces, but we've just put a bunch of PV on the top so we can mathematically say, well, we achieved net zero and we offset that. And I think the short answer is the team wasn't entirely confident that this definition of net zero was what we wanted at the core of an educational solution.
So the start of schematic design gave us a real chance to pause and ask some fundamental questions. Well, first of all, to achieve the net zero energy, the bundle 3 that we had offered up to the ministry wasn't funded. It was about $750,000 extra to make the net zero energy school. And in some ways, I'm kind of glad that they didn't fund that bundle, because we might have probably continued to go down that road because we came up with a solution at the PDR. Well, this fracture or this pause moment, as Monte said, allowed us to kind of step back and say, well, okay, we've been given the base unit rate for a school, but we've done all this work looking at energy. Why the heck didn't we look at carbon in the same depth or with the same rigor? Could we look at net zero carbon, and what does that mean? Could we achieve that within our current unit rate budget? Wouldn't that be fantastic? The ministry would be tickled pink, school district would be great, and we would be doing the right thing from a sustainability solution. We don't know the answer to that yet, but what we're doing is we're looking at a new track that looks at options that are alternate tender prices over and above our base building, that are in our base building design, that we think we can actually get pretty damn close to. And there's some other things and incentives that we're going to share with you in terms of how we think that we can achieve that.
So the standard we're looking at is called the Zero Carbon Building Standard. It's brought by the Canadian Green Building Council, or CAGBC. And the idea is that instead of offsetting the total amount of power you use, instead you commit to electrify the building, to taking any sort of combustion out. So you'll use an electric heat pump for the heat and the cooling, and some sort of a resistance or electric system for hot water, which of course is a really big load in schools. And you'll look at your electric grid. Now, the huge advantage here in BC is we have a really clean electric grid. And so most of your electricity you buy just from BC Hydro here, about 93% of it is clean. And so you only have to offset essentially that 7%. You also have to account your embodied carbon. That is the carbon that goes into the concrete and steel and glass and other carbon intensive materials of any building project. And so this sort of electrification as a path to low carbon, we thought was at least more consistent in terms of the message we would share, and probably more achievable, certainly in the southern part of BC, where your key tasks then are to electrify heat and hot water, and Patrick's going to talk more about that in a few minutes, and then provide enough solar photovoltaics or some other renewable power, but that's generally the most practical one at this point, to offset that 7% of non-grid in the hydro. So you can spend your money on the school enclosure and on the school systems, not as much of it on PV, and still achieve a standard that is meaningful at this point in time, and that at least is consistent at its ideology about reducing carbon. However, as you might imagine, this plan also faced some challenges, and 3 of them were that it was still more expensive to build than the current funding would allow. It is still more expensive to put in a heat pump system than a gas boiler. It's still a little different to put in electric hot water systems. And so we were still looking for ways to reduce the cost of building the school and make it more efficient. And Ray's going to talk about some great things he did with form factor and other issues in a minute. The second challenge, the second challenge was we discovered as we started consulting more closely with Surrey schools that the operation people at Surrey schools really liked their gas boilers and had learned to maintain them very well. And they were very much expecting another school based on gas boilers, not heat pumps. And they weren't keen about heat pumps and new technology. And so we realized that there's a loop to step back here and bring the operations people into this discussion more deeply. Help the operations people understand what the provincial and community and school board goals are. Also help them understand that the province's policy direction is headed towards electrification, perhaps as early as 2030. So even if we put boilers in some buildings at this point, we might not be able to replace them in 10 years or 15 years when they hit their end of life. We might have to move to heat pump at that point. And then finally, once our focus shifted to carbon emissions, what was coming out of the building through operations, we realized that it was really appropriate that we also look more closely at embodied carbon and do some calculations about the concrete and steel and glass and other pieces. So in subsequent, were you going to take this piece?
Yeah,
right?
sure. I can take this, Monte. So, we felt it was important to both in preparation for this presentation or the discussion, to actually talk to the ministry about what happened on 207, but also to understand what is the ministry asking current consultants and school districts to do in their PDRs. And, you know, a year from now, what will be the question or the option in and around energy? And, you know, in talking to the ministry, they said, well, you know, we can't really answer that question. We're working on it, but it actually doesn't relate just to us. It also relates to other ministries and other government bodies. So he said, well, let's talk to those guys. So Monte and I jumped on a call, and, you know, the message and the ideologies that I think the future is going to hold for us, I don't think we're going to be asked to be looking at net zero energy or possibly not even net zero carbon. I think the key ideas are going to be about looking at lower emissions, looking at clean energy. But the reality is that there's still no standard or timeline yet released for future PDRs. So we're hoping that some of our recommendations on this presentation will help inform some of those potential targets. In the meantime, on our project, we've actually gone ahead and received approval from BC Hydro for a pre-screen process for funding that requires an energy study, which we hope will help balance out that slight overage that Monte's pointed out for the cost of a net zero carbon building that is over and above the baseline cost that is the unit rate funded by the Ministry of Education. So, you know, I have to say, there's a lot of other competing things that are driving a design, and it's not just the study of energy. It's making the best building for the students. It's making the best building for the school district. It's taking lessons learned from past projects that the school district's built or is living in. But we, you know, in the PDRs, we start with the basics. And in our case on the left, that's the PDR option, looking at a two-story school. It's a bit more sprawling. It's got more envelope. It's got more glazing. It's got more roof plane. Hey, that's a great opportunity. You could load that roof up. You could fill that whole roof with solar panels, and that's actually what our option did. But we also looked at a three-story option that had the gym on the exterior, on the outside. Tried to make it compact, but, you know, it's concept planning at the PDR stage. Well, there's actually some key things. There's 5 key things that we wanted to share with you that we think is important, not only for energy, but in our case, we're actually, and I'm not sure if I'm allowed to share dollar values and numbers, but I think it's fair to say we're about $10 million in our first round of schematic design costing, $10 million over our construction budget. That's not project budget, that's construction budget. We had to do a lot of value engineering just to get to our baseline price. So we did a lot of these things, not only for energy, but also for making sure we could actually build the school and have a project. So the 5 key things that the basic ideas are compact form, making the building as compact as possible. I know you're all hearing those constantly from our QSs. They're always saying, make it as compact and as efficient as you can. And in our case, we wanted to do it for energy as well as cost. Reduce your glazing, repeatable structure, and because we're really keen on looking at this carbon sequestering, we explored wood, and I'll tell you a little bit about that, but also looking at your solar array. And in our PDR version of energy, we actually had, I'm not sure what the percentage was, but our entire roof was loaded with PVs. We are now looking at only a solar array of 7%, which starts to fit into a more affordable range. And then the last one is to really be simple with your mechanical systems. So in terms of a compact form, you know, we still want to achieve learning communities. We still want to have a certain pairing of grouping around learning neighborhoods. We wanted the school to have a heart. It's got a 3-story interconnected atrium. We wanted to put the gym in the middle, primarily because it made a more compact form, but it also actually really worked better for this 3-story vertical learning. In working with the school district, they thought the gym in the middle made the most sense, because you can imagine someone in grade 6 who's coming from their classroom on the 3rd floor. Well, getting to the gym is really easy now, as opposed to the gym being way over on one left side of the school or on the other side of the school. So that compact form being driven by a lot of key ideas, but certainly in our case on this presentation energy, it really certainly helps. Reducing glazing, we're looking at a window wall ratio of 30% window to 70% wall, and again, that's really helping with our energy and cost. And the other one is repeatable structure. We have a standardized module for each classroom and our grid, and we are mass timber on this project now in design development, and we've confirmed that through our costing exercises. So we're working through making that structure repeatable, measurable, and economical. And that's just a quick AXO from the Revit model. But the interesting thing is this project actually did validate. We ran 2 options. We ran a steel option and we ran a mass timber option. We managed to get about 90% wood into this building, and the only bit of steel that we have now in our current design is the open web steel joists and the HSS for the gym. We could not beat the price point of that, but we managed to go mass timber with metal deck, mass timber post and beam, glulam column and beams, and an entire framing of 2x4 wood frame studs. So we're hoping that through future testing with Athena, our carbon sequestering and what we're looking at that can become a benchmark, at least for our own work here in our office, but also we want to share that with everybody else. Again, the solar array, switching to carbon, the one on the right, you can see the difference. It just makes more sense to be looking at carbon because it's actually achievable within our dollar point. And then the fifth point, and I'll pass over to you, Patrick, is what are we doing to make our mechanical systems as simple as we can and to reduce carbon?
Perfect, thanks, Ray. Yeah, so as we're talking about, we got to reduce our peak heating loads. So as Ray was talking, that comes with simple building form, the window to wall ratio, keeping that down. If we can lower that peak, we can really downsize our mechanical systems and keep it a lot simpler. Of course, when we're going low carbon, we need heat pump technology for heating. We can't do it the traditional way with boilers anymore, so we really need that heat pump technology. And when we get into it, we're going to show basically how we can implement that heat pump in a cost affordable way. We need to talk about heat recovery, whether that's on the air side or the water side. Monte actually taught me a new word yesterday called kitty watts. And so basically using all those kids' energy inside the school to heat other parts of the school. And of course, electrification. So not only talking about heating the building, but we need to talk about domestic hot water production as well. So just to give you a rundown of our mechanical system, Ray's produced a pretty great sketch, isometric sketch there to kind of give us a good idea of what's going on. I'll preface this with that what we've kind of proposed here, the school district is fairly familiar with. So we're not going outside the box and giving them something and say, hey, good luck. So what we got here, we have classroom ventilators. They provide ventilation, heating, and cooling for all the classrooms. In our plant, we're proposing air source heat pumps to keep our carbon down. As well, we'll have a little bit of backup heating from boilers, and this is to do just with the peak winter loads so that we don't have to oversize our heat pumps too much. From that, we run a 4-pipe distribution system around our building for heating and cooling. And what we've done early on in the design, when we're looking at this, we actually, the classrooms were very nicely stacked. So one big cost saving, we were able to get a vertical distribution with a 3-story form. Another thing we're looking to is how can we run these heat pumps longer into winter and rely less on those backup boilers. And so for an elementary school as well, we know the domestic hot water load is quite low. The students in there not regularly using showers. Most of the usage is in lavatories. So instead of a large gas-fired central system with distribution losses through the building, how can we make this simpler? Well, we can get some electric hot water tanks, locate them in the groups of washrooms, and eliminate a lot of hot water piping around our building. One thing that kind of came late into the game is we were looking for basically further cost savings so that we can keep our air source heat pump in this project. Because basically without that air source heat pump, we're back to the traditional gas-fired system. And so something we're considering at this point is a 2-pipe seasonal changeover system. So get rid of the 4 pipes, heating and chilled, just do a 2-pipe, and we actually change that over based on the seasons. And so I think I put this slide in here just to maybe avoid a question later, but we did actually look at ground source heat pump technology and air source heat pump technology early on. And we basically found, once we realized that the funding wasn't there, a ground source heat pump does come with a more expensive price tag. And you get very small gains from it in a climate like we are in Surrey. So we decided to go with the air source heat pump And so something critical here that we were looking at is the air source heat pump, and how can we size this efficiently, because this is one of the most expensive pieces of equipment on the mechanical side. And so anytime we make that piece of equipment larger, the price tag goes up. So in this plot, it's a plot of the efficiency of the heat pump. And as you can see on the lower side, bottom axis, as the outside temperature gets lower, the efficiency also drops quite significantly. So how do we get a more efficient heat pump is, well, we've got to look at ways how we can design our system inside the building to lower that hot water temperature. And if we can do that, we can get away with a smaller heat pump and actually run it further into winter.
Okay.
And
great. Oh, sorry. Sure, go ahead, Patrick.
And I was just going to say, so there is lots of challenges we're coming with here to keep this heat pump, and the design team did struggle with it during design. And so I think the next part of this presentation, Monte is going to run us through some recommendations that we think would help make this design process and PDR stage a little easier.
Excellent. Thanks, Patrick. We've got about 10 minutes left before we need to open up to questions, and we've got about 9 slides, so that's perfect. Over to you, Monte.
Awesome. So these are some suggestions we'd like to share with all of you, and we really like to get feedback on. We're not saying we have all the answers here, but we think it would be useful if we stop working in silos so much with separate teams on separate PDRs and separate school districts, but kind of share data and compile data across BC schools. Actual gas and electric usage, both per school and per pupil and per climate age, compiled embodied carbon calculations, probably preparing them for schools that are either recently constructed or about to be constructed. If we had some sort of a formalized feedback from operations team to make sure the operations people are engaged in this discussion and understand how they see the evolution that we're all coping with. Some feedback on expectations of future policy. Is there going to be a step code for schools? What might it look like? What does the greenhouse gas reduction look like? And what targets or expectations might be we looking towards? And we know there's a huge electrification push in BC with an intent to electrify most buildings in the range of 2030s. And we think it would be great if there was some mechanism to compile much of this into a baseline report so that as any of you start a new PDR, you can quickly see what the benchmarks are we've been working towards in the past as you start to think about what a future benchmark might be. Next slide. The second suggestion we have is that what we did in this process is we picked a bunch of targets and we sort of made some choices and we settled on this CAGBC zero carbon as an option, but that might or might not be the right decision. And we made that decision very much in our own silo. We think an ideal process going forward would be for this school and maybe the next 10, but a reasonable cohort, and not all in the lower mainland, were to all model themselves to the same 4 or 5 standards. So we have a bit of a study and we understand what they could produce and what the costs might be. We would suggest looking at the CAGBC zero carbon at something like step 4 with no combustion. At something like a net zero process with no combustion, a net zero standard, a specific one, a step 4 like process, something like passive house. And that also we do full embodied carbon calculations for each one of these options. If we were simply to model 10 or 12 schools to all of these standards, we would actually have some really robust data that would allow us to find that sweet spot between costing and energy and carbon emissions savings. And then our final page of recommendations here, that after we have the baseline data, we know where we're at. After we have the modeling data, we know where we could go and what it might cost to go there, that there could be some sort of a process through which the ministry could set hard targets for schools going forward. And we would suggest those include or consider things like thermal energy demand intensity, TEDI, the total amount of heat and cooling energy you have to use, because that drives towards better enclosure options. Going to Patrick's point, if the enclosure were more robust, you can shave off that peak load that needed the boiler simply by having a more well-insulated and thermally defended in the summer school. A total energy use intensity, what's the total energy use per school or per pupil? a greenhouse gas intensity limit, what's the emissions limit that's acceptable and part of provincial policy, an embodied carbon limit, how much carbon are you going to sink into the concrete and other materials in the school, and especially coming out of COVID, to have some specific ventilation requirements for schools in the future so that we understand how we're ventilating for safety in the case of future events like this. We would note that these kind of targets have been established elsewhere. The London Energy Transformation Initiative has specific targets for schools in the UK, and they're about 65 kilowatt hours per year total energy, and heating or cooling energy of about 15 kilowatt hours per square meter per year. So hard limits that they manage towards. And they also have an embodied carbon target. You can see it there on the right, of 600 kilograms of carbon equivalent per square meter of school. Now, they build mostly masonry schools in the UK. We actually think we could beat that number out of the box today. We think Site 207 will beat that number. So these may or may not be the exact targets we want to choose, but we are suggesting we start a process that would bring us to hard targets like this we could all manage towards in the future. I think we have one left. And we would note that, there are other jurisdictions around North America that are trying other things. There's quite a few passive house elementary schools that have been constructed in the state of Maine in the US in the last years, 5 or 6. And they're producing schools at reasonable price points. The Friends School there on the left was built, I think, about 3 years ago. I need to check, for about $200 US per square foot. Wainfleet on the right, which is a private school, a little higher end, and it's in the city of Portland, so it has some more urban type requirements, was closer to $350 a square foot just about a year and a half ago. But again, these are not crazy numbers for high performance schools that deliver a lot of durability, quality, and comfort.
So what we're doing on Site 207 on Tattledoo, we are setting our targets, we're monitoring them, and we're seeing where it goes. And we want those to be shared with everybody else here on this call so you can see how we did, but also to inform what we might do next as consultants, as school district owners and operators, and as folks in the ministry. So we strongly are realizing that we don't lower costs by lowering standards. So often we design the best thing we think, and then all of a sudden we're just shaving and cutting and shaving and cutting. What we need to do is lower costs by starting smart at the beginning. Start with the most simplest form, start with the most basic approach, and then you can build on that. And we need to work as a collective to solve this. There needs to be, in order, I think, for the ministry to set targets, there needs to be baselines and a sharing of knowledge so that there's comfort and everybody knows what those targets are, and that those targets may move over time, and they will move over time. But right now, what's not happening is I don't believe there's a collective of information that's being garnered throughout the province as it relates to what are our energy targets for schools. So I hope this has somewhat debunked the myth of net zero. You can certainly see here, we're actually not really even going in a total net zero direction anymore. We're looking at these targets. We're looking at different ways of thinking about energy. I'm going to open it up to questions, and thank you very much to the A4LE for having us. Our contact information is on the slideshow. If you don't get your question in here, you want to contact any of us, we're all here. And I'd also like to maybe ask Mo and Selena if you can turn on your video and your sound as well, in case there's questions that might come up that you would be more specific to answer. Thank you. Thank you very much. Are there any questions?
Yeah, I have a question.
Enrica, yeah.
Hi. Hi, thanks so much for the great presentation. Couldn't agree more. As you probably are aware, we're right behind you guys, working with the same school district on a different site, and on a PDR with the ministry, and kind of learning, having a bit of an opportunity to take some of the lessons learned, but I think we're too close behind for the ministry to actually have rethought their approach. And so they've still given us the similar guidelines as you guys have. And totally agree with the assumption that, net zero as a definition is kind of a really hard one. And wanted to share with everybody here that one of the complexities that we're seeing is when we are investigating net zero and the positive net present value, which are two things that are very impossible to marry in a school under the current unit rates, is that if you're talking about electrification, and we're going sort of in a similar route where we're trying to maximize energy savings and maximize carbon reductions, and the way to do that is through electrification. But what we're seeing is that oftentimes in new sites, like the school district that we're both working for, the sites are undeveloped. They have to bring their own services in. There's actually an upgrade to the electrical services and an associated cost with that. And so and what we're seeing is that what the ministry is asking for a net zero ready option, that you're actually putting a lot of capital cost in upgrading your electrical services to a size where you can account for that electrification. But then once you would put your solars on later on, that might, you now have an oversized electrified system. And so I was wondering if maybe I see Monte nodding vigorously. So what would be some of the, Ray, you're saying you're targeting, I believe, a 7% solar. So can you maybe elaborate on in your team? Am I understanding correctly that you're just saying, okay, well, this is a reasonable amount of solar array that we can use to partially create some of the energy, but we're not going to be offsetting all the energy? And how did you get to that number?
Yeah, yeah. So I'll just give a high level, and then I'll let Monte and then Mo hit it. But it's because of the fundamental decision, we weren't targeting energy anymore as net zero energy, but targeting carbon, and that's why the 7%. Yeah. So that's a fundamental choice, and we didn't realize that at the PDR stage. So does it increase your kVA on your transformer size and all that kind of stuff? Monte, your thoughts?
So this is a great moment for education.
Yes.
Under BC Hydro's current rate structure, which they can't change arbitrarily, they have to go back to Utility Commission to get a change. They are required to charge clients of new projects for those hookups. So you're right, you're paying a premium to move towards electrification. And this applies to not only schools, but to all projects. Conversely, under Fortis regulation utility, they get a subsidy from ratepayers and others so they can provide free hookups. In fact, they're going back and asking to renew that subsidy currently under the provincial law. So both organizations are behaving well within their mandates and well within what's been agreed to, but one is subsidizing the connection and shipping in others, and the other is charging the projects for the connection because they had different goals when those things were sorted. And I think a big part of what's happened in this province is we've changed our objectives as a province, but we have not changed our utility regulation. And so it's created an unfortunate disincentive for projects headed in this direction. And very few, it gets real nerdy fast, and I oversimplified that a lot, and I'm sure lobbyists for each were here, they'd correct me on several points, in fairness. But to create more awareness around this and have a new discussion about changing and leveling that playing field is absolutely critical for all buildings.
Mo, what are your thoughts on the transformer kVA size?
So definitely the starting point, even before we start looking at mechanical systems and electrical systems, the fundamental basis of the design with Thinkspace was to reduce the overall energy consumption of the building. So by first fixing the insulation and fixing the windows and fixing the window to wall ratios, getting all of those aspects right, it resulted in a smaller electrical mechanical system that's required. So if we just took a highly inefficient building, you would end up with a much larger heat pump and have significant impact on the electrical supply. But if you reverse that, make the building super efficient, you would need a smaller mechanical system. So the impact on the electrical side was fairly small, but yes, it did result in a larger size. So on average, elementary school of this size, the standard PMT size is around 300 kVA. With this system, we're able to bring everything within a 500 kVA PMT limit, which is still within, in Surrey, we're allowed to go up to 1.5 megawatts, but in other districts where the voltage is 12.5 kV, 500 kVA is the limit of a PMT. Once you exceed it, then it's going to result in a unit substation being required. So I think just through clever design on the building envelope, we're able to still minimize what the electrical impact was. The 7% of PV, as Ray did mention, we initially did the school with the net zero study. We covered almost every spare space. I was fighting with Patrick and trying to get rid of mechanical equipment from the roof, just so that we could have more PV panels. When we changed our vision and looked at carbon reduction, we actually followed what the city of Vancouver has mandated. And they're saying that if we're using pure 100% electrified BC hydro energy, as long as we offset 7% of that total kilowatt hours per annum, that's where we get the 7% from. And if you look at the graphic that's on the screen at the moment, we're able to do that with just, I think it's about 25 kilowatts of PV.
Hopefully that gives you some answer to your question, Enrica.
Yeah, no, it's great. And it's, I mean, if we had collectively solved it, then we wouldn't be talking about it here. I do want to, I totally agree with your approach. And one of the things, if we're sharing information here, and maybe it's a shameless plug for our energy modeler, but what we did for this project is, you know, I think we're all familiar with the way of we design a building. We use our best judgment and our experience to design a building that we think will perform well, and then we get it, you will get it to a certain stage, and then we get it modeled. And what we did is we tried to actually turn the process around. So we're working with Integral. They have a program called Integral Drive, and what we did is, even before we started designing the building, we got together with the whole team and we set certain targets electrically, mechanically, certain ways of backup systems and primary sources of heat, and window to wall ratio. So anywhere from like 30%, 20%, 40%, 50%. And then they have some sort of proprietary system that calculates all the millions of possible combinations. And then you get together and then you start setting your targets to say, oh, we want a positive net present value, or we want to reduce carbon as much as possible. And then it kind of reduces the number of options. And so out of that rolled our options, where we are having 3 different options with different window to wall ratios, different lighting intensity densities and things like that, R values for roofs, R values for walls. And so I think in the end, we're all kind of working towards the same goal. But the PV and electrification discussion has been a hard one, because yes, you, on the one hand, you were being asked to electrify our buildings. On the other hand, we're being asked to not increase any of the capital cost. And then in addition to this, we're also working on a 3-story school, and we've had some discussions with the ministry. The ministry says, well, you have to reduce your energy this much that all your PVs fit on your roof. And so then it would be more efficient for us to make a flat pancake 1-story building, but that's not the sustainable thing to do either, because land is becoming very expensive. It's becoming a valuable commodity. And so we're kind of pushing back. And also, I think the last thing I want to maybe give to everybody in this discussion is that even though the net zero carbon reductions and things are very important discussions, we should always look at them in a holistic approach and what's the right thing to do for the site and such. Because if we had gone down the path that we would have been steered by the ministry, the whole site would have been covered with a 1-story building, and that's not sustainable either, right? So thank you again for sharing, and I look forward to any further discussions. I think we should all share our information, so thanks.
Likewise. Thanks, Enrica. Are there any other questions? We've got about 2 more minutes. Are there any other questions on the call? Just turn on your mic and your video.
Ray, I just wanted to ask a quick one. Remember at one of our conferences, I think the last conference that we had, the ministry rep there launched this idea of the PDR section that was going to look at net zero and this net present value target. And there was a lot of questions about, you know, how far will we take the design in the PDR in order to make something realistic? And then there was some hint that the ministry suggested that there would be, once you prove the case, there would be separate funding from the provincial government to achieve that. So if there was a premium to get there, that wouldn't be part of your base budget for the project. That would be extra money. Is there extra money?
Well, I can't speak for the Ministry of Education or any other government or Treasury Board. I mean, that was at our last A4LE conference, and that was maybe startling to hear about all this work we had to suddenly do and look at net zero. Well, what we just kind of demonstrated to you was the work that was done, and that what the ministry described is what we just sort of presented to you as that exploration. And you know what Studio Hub's working on and what Thinkspace is working on, those are those explorations or PDRs. We're asked to show and demonstrate the financial value of those options in and over above unit rates, so that if there is extra money, I suppose it is equated to that difference in the number. Where that money comes from, I'm not sure.
So at the end of the PDR, essentially, they just wanted to know what that number was for their own research. They didn't say to you, okay, we'll fund that.
What they said is thank you very much, and the ministry actually went to bat at Treasury Board for that option. They supported it. It was turned down, and ultimately what was funded was the baseline school. So you know, the allies and the relationships with the ministry are very important, and they work very closely with us on these PDRs and projects, and they're very much team players and helpful in the process, because we're learning together as we go. You know, none of us are experts and can know everything. So it needs to be something that we all bring to the table and just be curious and ask the questions. Yeah, someone has a thought on that, Monte?
I'll try to be brief. I mean, I understand the ministry's position that it is very politically fraught to give more money to one school than another, even if it's for the very, very good purpose of meeting a cost premium for electrification or step code or passive house, that it puts them in a tremendously difficult position. So I have some sympathy for their, political realpolitik problem. That is the genesis of the suggestion we're making, and we're open to feedback and modifying it. We're not claiming we have this all figured out, but to see if we can get the ministry engaged in a modeling exercise and looking at several schools in several ways, but in the same ways by different teams, like Anarique's team and something you might work on, Amy, and others, you know, to really gain some data and some wisdom, and then set a clear baseline that every school has to hit equally, and every school's new unit value would include whatever seems appropriate to hit that. But the thinking behind this suggestion was, how do we do this in a way that the school ministry never has to put more money into one place than another, and never has to play favorites between Lower Mainland schools and rural schools, and those politics can be addressed in the most fair, equitable, and transparent way possible.
I think we're at our time limit. I'm going to ask Danielle if she wants to close out anything for this presentation. And if there are questions, emails for all of us on the call are in the presentation. So Danielle, if you're there.
Yes, I am.
Yeah.
Thank you so much. That was very interesting. Great presentation, Ray, Patrick, and Monte. It'd be good to have something to like a follow-up. Like you guys are putting this PDR in, you're making all these suggestions, recommendations. Anarique, like I think maybe down the road in the fall, we should look into some sort of follow-up session, maybe trying to get somebody from the ministry, because they normally come to our conferences, and wondering if it's possible to do some sort of follow-up with them. So I want to thank again Ray, Patrick, and Monte. That was a great presentation. Before I forget, I would also like to thank Donna, our tech person, putting this, the Zoom meeting together, and letting us in and out of the chat room and to participate. Because for me, this is my first Zoom conference, so I'm still a little bit nervous about it, but it's getting better. you know, for the future, like we're going to be probably in this Zoom virtual room for the fall. Like I said, there's not going to be a fall conference. We're going to try to organize a session like this. I think it's been a great way to communicate and exchange. I really like the question period at the end and getting some of these questions activated and seeing faces, because we're not seeing as many faces anymore. So I think as council, we're going to commit to organizing more of these sessions. I think we're getting a sense from people that lunch is the best time, because you're going to eat lunch and then you can listen to meetings. So we'll try to put some thoughts and try to keep you involved and excited about being members. At the same time, I'll ask of you, the membership, to please feed us questions, feed us ideas. If you have a great presentation that you'd like to share with other people, we'll put it together. Just send us a contact. We are going to be on our website. Your council member is going to be listed with our contact information. So we might also follow up with a survey and get your ideas if you like the format, the Zoom format. So please, thank you for everybody who participated and attended. Look forward to working with council for the next year and get some little meetings happening. Anybody else from council, any comments, ideas, words?
I just wanted to thank everybody for, it's Carrie Magnus. I just wanted to thank everybody for allowing me back on council, and to congratulate everyone on our first virtual meeting. Yeah, the presentation was fantastic, and I think this is going to be the way we'll have to connect for the next little while, and I think it's worked out really well. And thanks to you as well, Donna, for making it all happen for us.
Okay, so stay connected, stay safe until we meet again. Thank you so much. Bye.